Good morning, ladies and gentlemen, and welcome to the Sprint2 review for the TGMS capstone project. Here's our agenda. And our capacity.
Our main goal of this sprint is to build a working GUI on the Raspberry Pi that runs using sample data. We spent more time creating the GUI due to relearning Tkinter syntax and accidentally straying away from the product owner's vision. I also worked with Cadet Sun in converting Cadet Stark's code for Raspberry Pi use. This is still a work in progress due to Cadet Stark's code being harder to comprehend than initially anticipated. To organize our responsibilities and to keep each other accountable, Cadet Monkhurt developed a racing matrix for each individual task within this sprint. During this sprint, we worked on the low-level user interface. This was our initial design, and we spent some time creating this design on Tkinter. However, when communicating with our product owner, we realized that we were straying away from his vision of the user interface. The main intent of the low-level user interface was to display the appropriate generator size and possible course of action if needed. With this information, Cadet Monkhurt and myself created a very simplistic GUI design, emphasizing whether the generator size is optimized or not. Like I mentioned earlier, we are still in the process of incorporating Cadet Stark's code within our project. For this sprint, we created a sample code in lieu of an actual generator. We are incorporating a dual micro USB for power, a TTL serial cable, and a female-to-female USB converter for constant connection by the high-level user.
This is Cadet Anderson. For this sprint review, I worked with both Cadet Stahl and Monkhurt to finalize the connector type we would use in the system design and develop a high-level block integration diagram, respectively. After talking to Dr. St. Ledger, it became obvious that our tactical generator monitoring system would not be able to serve all size loads. We agreed that there may have to be two versions of the tactical generator monitoring system, one that can serve higher power loads and one that will serve lower power ones. We decided that we would be in the market for lower power loads and would thus cap the load size to a 50 current capacity, serving as a constraint on our design. This constraint helped us to fine-tune what kind of parts we were going to need to order for the system. In terms of connectors, this helped us choose the connector that had a max capacity closest to 50 amps. As per Colonel Shea's recommendation, I looked at the MIL DTL 22992 Class L connector manual to find the connector that would be best for the design. The first design aspect we had to choose was whether it was to be wall-mounted or a straight plug. This is a pretty easy design choice because we were dealing with a portable type design, so a straight plug made sense. Next, we had to choose which side would have the male-female connectors. Since the monitoring system connects in series with a generator and a tactical power distribution unit, it would use a male connector to connect to the generator on one side, and then after it passes through the monitoring system, have a female connector at the output and to connect to the power distribution system. The 60 amp power rating was the closest rating to the 50 amp design limitation we chose for this system. Since all of the generators we were serving have a 3-phase 4-wire capability, we chose this configuration, which is pictured on the lower part of this slide for the configuration of the connector. There are a few generators that have the ability to serve a single-phase 2-wire system, so choosing this type of connector might also be used for a follow-on design. In terms of building the part number that we needed to order, we had almost everything we needed. The manual made it pretty easy to make a part number following the above steps, and I feel confident that we have the necessary information to order the 2 parts listed below. I have depicted a quantity of 2 for the sake of having spare parts for the project. Aside from finalizing the exact connector we chose for the project with Cadet Stahl, I also worked with Cadet Monkhurt for the sprint to make a high-level block diagram of the tactical generator monitoring system integration. As you can see from the diagram, the monitoring system connects in series between the generator and the tactical power distribution unit. It uses a current transformer to track the analog signal delivered to the load. It discretizes the input, delivers the power delivered to the load in real time to the user, and stores it in a database that is used concurrently to make load level and generator sizing predictions.
Cadets Stahl and Anderson worked together to find the right connector part for TGMS. I reached out to Mr. Scanlon, an employee at the West Point Motor Pool and LRC who maintains the West Point generators. We scheduled the time to meet with him, and Cadet Perrier and I drove out in a high-mobility, multi-purpose wheeled vehicle to meet Mr. Scanlon at the motor pool to get hands-on with the tactical generators and see which connectors would work. Unfortunately, it was a code red that day and Mr. Scanlon was not there. He then notified me a couple days later that he did not actually have the tactical generators we were looking to take a look at. I had a class in power with Colonel Shea, and she briefed a lesson on tactical generators. She talked about a power distribution unit and explained to me after class that our TGMS only needed to connect in parallel between the generator and the power distribution unit. She also recommended that we used a Class L MIL DTL 22992 connector part.
Potential transformers, also known as voltage transformers, are able to step up or step down voltages and are primarily used for measuring, and achieves accurate voltage ratio and voltage regulation, while power transformers transform power from one circuit to another while either stepping up or stepping down voltages. In my search, I searched for voltage transformers but was only able to come across a company called FlexCore that made low, medium, and high voltage transformers. However, it would only step down voltages from 600 to 120 volts at the most. While speaking with Mr. Mosquera, he taught me how to utilize websites such as digikey.com and Mauser.com to filter the secondary voltages required for the tactical generator monitoring system. Filtering out my options led me to the F-8X power transformer. Upon the power product owner's questions, he noted that the power transformer was not designed for sensing. I contacted FlexCore to see if they could make a customized voltage transformer that would achieve our results, but I'm currently waiting on a response. For our purposes, we plan on utilizing the F-8X power transformer as a step-down transformer for the analog to digital converter. Since we are unable to find an exact match of our specification, custom orders may be necessary. This is a paper prototype of the TGMS, only including the current transformer and the proposed power transformer. Based on the dimensions and spacing, we expect packaging to be roughly 6.5 inches in length, 5 inches in width, and 3 inches in height. The schematic is scaled to its dimensions.
Hello, this is Cadet Perringer. During the sprint review, I went to the off-post generator facility with Cadet Stahl. I finalized the A to D converter choice, called current transformer manufacturers, changed our current transformer model, and coordinated Raspberry Pi wiring with Cadet Mukhtar and Cadet Bondoc. The Tuesday after Thanksgiving, myself and Cadet Stahl went to the off-post generator facility after instructor recommended it for increased understanding. The facility was closed to all but contractors as it was code red that day from snow. We later decided, for the sake of time, to X that trip. I also worked closely with Cadet's son to choose a current transformer. After the further discussion with manufacturers, we decided to choose a smaller mounted current transformer that would better fit into our product dimensions. The hardware connections into the Raspberry Pi needed to be coordinated with IT personnel to ensure there were no conflicts. We prioritized the ADD high precision shield. As the digital signals that this would produce were essential to having any data analysis.
For our goal assessment, we mostly achieved our sprint goal. We created a basic GUI design for the low-level user, and we ordered our parts for the project. We also complete the design of the project. Currently, we're still in the process of converting Madison Stark's code into our project. Recommendation: communicate design with the project owner at the beginning of the design process to ensure the project is meeting the product owner's expectation and not wasting time. We had this problem when creating the low-level user design, and we wasted a lot of time on work that will not be used in our final project. And this is our product roadmap.